Okay. You guys can hear me? All right. So we put together a presentation here on how to leverage OCP to create purpose-built ARM processors, advancing it forward. I'm Zach from AMI, and
I'm Jeff from Arm.
all right. So what are the challenges facing the industry today? You've got to scale to meet demand. Basically, infrastructure needs to change rapidly based upon the workloads coming in. Also, hybrid environments are now the norm. You heard even Geico during the keynote. People have gone to public cloud, they've gone to private cloud, now they're bringing stuff back on premise, so you've got to be able to handle complexities of infrastructure existing everywhere. You've also got non-homogeneous architectures and non-homogeneous vendors. So you've got a multi-vendor environment. You've also got a multi-silicon environment now. You've got x86 probably historically. You've got ARM coming in now. You might even have some power. And you've also got additional products that are involved in the computation now. You've got smart NICs, and everybody knows GPUs because of the next slide. AI is everywhere. So AI is being used in all sorts of ways that people hadn't even imagined a couple years ago, whether it be in 5G and telco, automotive for self-driving, healthcare for looking at and diagnosing issues, industrial IoT for preparing for things on the factory line, client computing because everybody likes to be able to generate some things or ask AI bots questions these days, and also in just general generative AI. So how did workload optimization happen historically? A lot of times when we started this decades ago of workload optimization, people focused on compilers. How can I create the most optimized code output or generative code output? Then there was hardware virtualization that people used because how do I make my hardware more better utilized across all of the compute that I'm trying to do? Then we made further advancements in actually, why don't we use containers? Because I don't need to virtualize the hardware. I just want to virtualize the use of the hardware more than anything else. At the same time, in today's architecture, we're also doing a lot more in the hardware. There's fabric to be able to connect machines to make one giant machine. I think everybody saw the contribution of NVIDIA during the keynote as well. There's also GPU cards that are much more now even the primary compute or the primary used compute in a platform. And you've also got smart NICs to offload a lot of your networking functionality. So ML's driving a lot of this. I think people have talked about 3 different epochs of ML. Like there was early, we're now in the fast advancement, and we're going to an ultra advancement at the same time. Basically, the amount of compute is not going to decrease anytime soon. We're doing more and more compute for more and more complex problems. So that kind of takes us to where we wanted to start the discussion of making purpose-built silicon for your specific workloads. The easiest one to point to who's done this for generations already is Amazon and their Graviton product. So they started several years ago putting out their first Graviton. What is Graviton really good at? It's good at running container orchestration. It's good at running web servers. What does AWS run a lot of? Web servers and container orchestration. So they've basically tailored their silicon to start executing on what they are running the most of so they can get the best value for their customers. They even charged cheaper rates for the Graviton processors when they came out because they knew that they were going to get more bang for their buck using these types of silicons because they were built for that specific purpose. Also, it continues to improve with Graviton 3 to Graviton 4. There's some stats there from Amazon on how much performance they're even getting generation to generation.
And it doesn't just stop with Graviton. We see that, other big companies like Microsoft and Google are starting to look at custom silicon for not just processors for Azure or for Google Cloud, but also developing DPUs, IPUs. They're developing tensor processing units. Amazon is also developing their own AI unit. I mean, NVIDIA has Grace Hopper, which is very purpose-built for AI. And so we're seeing a big trend towards custom silicon. But at the same time, there's lots of pressure on custom silicon. Custom silicon is very attractive, but it's also very costly. It's costly in terms of dollars. It's costly in terms of experience needed, and different segments like AI, telco, automotive, all of these people want to have custom silicon, but the requirements are going to be very different, and sustainability is going to have to underline all of this. So at ARM, we've traditionally offered sort of just a wide portfolio of IP. Maybe that's cores, maybe that's fabric, system IP. And this approach has worked well for people who are used to integrating silicon, or for those very large organizations that decide they want to take this all in-house. But we've had customers come to us and ask and saying, hey, ARM, can you do more to help make this easier for us to get into building silicon? And so then we went ahead and started with the CSS initiative. This is a compute subsystem. Really what this is ARM creating a sort of blob that you can put on your silicon, and it makes compute, the boring part, general, and then you can go and start focusing on your custom differentiators like accelerators or signal processors. And really the next evolution of that now is to move towards a chiplet ecosystem. And so we're starting to work with partners to enable chiplets based off of ARM CSS. And what this will really do is it'll allow people to have a faster time to market and to be able to build silicon that is custom for their needs. Oops. So this program is called ARM Total Design. It launched a year ago. And we're now in sort of the phase 2 of this, where we're working with providers and vendors, and we're giving access to CSS, we're doing trainings, and the next goal of this is going to be creating a wider chiplet ecosystem. And there's really a lot of diversity here, right? There's lots of companies coming into this, there's lots of things happening. And with all of these vendors and all of this, these chiplets, it's going to add a lot of new complexity in terms of firmware, in terms of interaction between chiplets. And it's not just for hyperscalers. So we have partners who are in the telco space, partners who are looking in the HPC space, and in the networking space. And ARM is also doing other efforts beyond firmware to try and make sure that we can create a reusable chiplet ecosystem. So we're helping drive industry standards. We're opening up some of our things that were traditionally more internal and extending them to multi-chip interfaces. And then we're also making sure that we have a portfolio of IP that works with this chiplet ecosystem. And one of the big deliverables, and the one that's most relevant here, coincides with our fixed virtual platform. This is a system simulator. We offer various configurations with the V cores that are high performance and cores that are a little more targeted towards cloud computing. And all of these are freely available. I think you just have to sign an agreement when you install it on your machine. And alongside this, we offer reference design firmware. This is open firmware that you can just go and download and start developing before you have your silicon. You can start working on your software, on your firmware, and sort of shift that development to the left.
So along with closely working with ARM on their open firmware that they're doing on these platforms, we also spun up our flagship product, Apptio 5, for boot firmware on FVPs. So this allows you to quickly get started. You want to put your toe in the water. Do I want to create my own ARM custom silicon? Start with the FVP, test it out. We can offer you support in this case. We can help work with you as you're going further down that road of, okay, I now have convinced myself I want to create purpose-built silicon. Now, at the same time, why are we talking about this at OCP? OCP is the perfect place and cross-section of I want to say competitors, but an ecosystem that really helps get you to the point of being able to design your own silicon and your own platform. It's got AI groups focused on how to integrate your AI, your DC facilities, on how to integrate your platform into the ecosystem of a data center itself. Hardware management is probably one of the best ones to start with. But basically, throughout all these groups that I've listed there, you can get information on how to design your own board. There's plenty of x86 and ARM designs that are already contributed to the foundation itself. So you can take one of those to start designing your silicon around it. So it's almost an open ecosystem for board design for people who are getting started in this space. There's also a lot of industry specifications and projects out there to enhance this. And at the last note there, you should contribute back. That's why this ecosystem exists, not only to promote, but also to get feedback from others on how to improve your own design. OCP has been proven on this for almost 15 years now. Now, okay, you've convinced yourself you want to create your own silicon. You've even convinced yourself that you can create your own board. What are some of the gotchas out there to think about? When you're using traditional platforms, people don't realize that in your processor, there's more than just the main cores that are used for execution. There's also additional cores on that system that are not exposed, but provide management functionality, provide RAS functionality, so you can get information on failing memory or failing other components in the board. And it's also got security functionality for a silicon root of trust. So you do need to think through, do I want to enable these? Probably. How do I want to develop the features for them? Do you want to work with somebody who can help you with it? That's great as well. And maybe OCP and OPF, the tracks that we're in here, are the right place to maybe target working in some smaller groups on how to design or at least spec out how these different things should function cross-vendor. Now, when we're discussing cross-vendor, firmware tends to be one of those things that people forget is even there except when it's not working. So it's honest in that you're going to have a multi-vendor environment, whether it be your silicon and also silicon available in the general market. But starting with a common base as you're building your firmware is the best route to go. It's going to offer you the maximum compatibility with what you're currently running. And you might as well fix security issues once and deploy everywhere. You want to develop a feature once, deploy everywhere. So this is kind of common sense, but I do want to point out to everybody that starting with a common base is your easiest route to go. So we talked about a lot of topics here. Let's kind of summarize some of them. Making purpose-built silicon is more possible today than it ever has been in the past. The benefits are now outweighing the costs behind it. As Jeff talked about, they've done specific things in the CSS and ATD program to decrease your costs and prepare you for this as much as possible. OCP is the place that you can really pull all of this off because the ecosystem is built around manufacturing and integration within your data center. Chiplets are definitely the future of the industry. So I know we talk about it every year, chiplets, chiplets, chiplets. We're potentially not all the way there of where you can plug and play chiplets across multi-vendor. OCP and ARM are definitely doing big things about this for their open chiplet ecosystem. The Neoverse program from ARM is going to accelerate all of the design capabilities you have. And again, using common firmware is your best methodology for maximum compatibility. Call to action, I'll start with the bottom one because as the previous presenter pointed out, you now only have 33 minutes to come by our booths. But optimizing silicon to your needs is now a must. Obviously, the vendors are going to do it, but do you want to get ahead of them? Get involved in all of these groups in OCP because at least reading the material and seeing where they're going is going to give you in-depth knowledge of what data centers and what other people are really thinking. UCIe definitely needs some work too, and they're doing a lot of great work to integrate it more with OCP and other vendors. And OCP is your best resources for this. Some links to DC.
Yeah, and also please check out, we'll have links here for ARM Total Design and the ARM Neoverse for the IP and the CSS. So.
Yep. So I think we were a little bit ahead of schedule. I think we've got 3 minutes for questions now, if there are any questions. Oh, I mean, yes, if you don't have any questions,
yeah, I'll go check out the booth, yeah. You can get there and back before the next session.
But any questions? All right. If none, thank you very much.
Thank you.